So good morning students. In the last session we learnt about the Ohm's law and the verification of Ohm's law. Yes. What we observed there, no? We observed that the current through a conductor is directly proportional to the potential difference applied across that ends of that conductor. That is V proportional to I, keeping all the physical conditions remain same. For example, the temperature and other physical condition. Yes. So V is a proportional to I, and we learnt about a new term, that is a proportionality constant, which is known as the what? Resistance. Yes. So this resistance we determine by this with the help of this law, that is V by I. This thing we determine. Okay, so we will learn more about today about the significance of this resistance. As you know, the resistance measures the obstruction to the flow of current. Yes, in many appliances we need some more current or the less current. Yes, means according to the requirement. So from this above relation, it is very clear that this I is inversely proportional with R. Let us just verify this thing with the help of an activity. Yes, so let's have the activity. Okay, so we will now study about the electrical resistance of conductor with the help of this following activity. Yes, so for this activity, what we need a resistor, a bulb. Let's see real diagram. So a resistor, a bulb, wires, ammeter and cell switches. Yes, so now first of all we have completed the circuit. Yes, and now we have provided a gap where in this gap we can fix either a resistor or bulb to observe the dependency of this resistance of the current. Yes, so now first of all the circuit is open, so you can see no current is flowing through it. Yes, now what we do, let us just fix in this gap a nichrome wire. Yes, let's fixed a nichrome wire. Now as you can see, its resistance is of 5 ohm, right? And let's just start the switch. You can see the circuit diagram also. You can observe the flow of current, and so let's see this thing. Now for this 5 ohm, see the value of current, no, it is 1.20 of ampere. Yes, you can see the flow of electrons also, that you know flows from positive to negative, and conventional direction of current is positive to negative. Okay, by the way, come to the point. So for this 5 ohm of resistor, the current flowing through it is 1.2 ampere. Now replace this thing with this bulb. Okay, so first of all disconnect the circuit. Okay, now we cut from here. Okay, now we will connect a bulb to it. Yes, so bulb is fixed. Now turn on the switch. So let's turn it on. Okay, see, blows, the current started to flow. Yes, now see how much of this value, this is of 10 ohm resistance. Yes, and the current flows, it is what, 0.6 ampere. So what we observed here, we observed what, ammeter reading differ for the different components, like the bulb and resistor. So we can repeat the same experiment with the other things also, but with the two we observed, what we observed, the current is different for the different components. Oh, the question is coming, why do differ? Because what happened with the certain elements, they offer an easy path, means which are having less resistance, they offer an easy path to flow of the current, while others resist the flow. Yes, so we know that now motion of electron in the electric circuit constitute an electric current. Yes, So which allow the easy path, they are the good conductors. Which obstruct the flow, they are known as a resistor. And which mostly resist, they are known as the insulators. So I hope so you understood the dependency of resistance on the current. So I hope so you understood the activity, and through that activity we learned about the conductor and insulators, that which provide a less resistance to flow of the current are known as a conductor, whereas which provide very high resistances are known as generally insulators. So the they obstruct the flow of the current. Yes, so on the basis of that we can define a resistor and a variable resistor which is used to obstruct the flow. So a conductor having some appreciable resistance is called a resistor. Yes, and a variable resistor means which will have the different value of resistance, but it is a kind of component, which is used to regulate the current without changing the voltage. Okay, the voltage source is called the what? Variable resistance. For example, in the Ohm's law activity you have observed about the rheostat. So that is a type of variable resistance. Now students, we will try to learn that what are the factors on which the resistance of conductor depends on. Yes. So let's just try to get it. So from an experimental, on the basis of the experiment, it is found that the resistance of a conductor depends on the very first thing is about length of conductor. Length of conductor. Okay. The second thing, and okay, how it depends. So generally this resistance is directly proportional with the length of conductor. Means अगर आप लेंथ को बढ़ाते हो तो उसका रेजिस्टेंस भी क्या होगा, बढ़ेगा, और लेंथ अगर आप घटाते हो तो उसका रेजिस्टेंस भी घटेगा, है ना. Then second point is about area of cross section. Area of cross. So generally resistance is inversely proportional with area of cross section. मान लो ये कंडक्टर का एरिया ऑफ क्रॉस सेक्शन है, ये एक वायर है ना. दिस इज अ व्हाट, एरिया ऑफ क्रॉस सेक्शन. अगर ऑब्वियस है, अगर आप किसी भी चीज के एरिया को बढ़ा देते हो तो यू आर प्रोवाइडिंग द मोर स्पेस. सो हियर द नंबर ऑफ फ्री इलेक्ट्रॉन्स विल बी मोर, or you can say the charges. So if it is a two-way, so more free charges will be available, and thus the current will flow more and the resistance will be less. Yes, so it is inversely. And the third thing on which it depends on the nature of the material. Nature of the material means obviously we learned it ना. अगर मेटल्स है तो जनरली मेटल्स जो होते हैं अच्छे कंडक्टर होते हैं, है ना, और नॉन मेटल जनरली बैड कंडक्टर्स होते हैं. सो इट डिपेंड्स ऑन द नेचर ऑफ द मटेरियल. ओके, सो व्हाट वी कैन डू, वी just combine this two equation. Okay, I'm writing above here. So erase this thing also. So we can say this is L by A, combining these two equations. So here is a proportional sign. When we remove it, we need to put a constant of proportionality. Yes, so this is R is equal to rho L by A. Yes, so this is another physical quantity which is known as a resistivity. Yes, where rho is a constant of proportionality known as rheostat. Sorry, resistivity. Sorry for that. है ना? constant portion known as a resistivity. You can pronounce it as a rho, RH-O. Yes. So these are the factors on which the resistance of the conductor depends on. Generally, this is another physical quantity we are going to discuss now. What is this resistivity? Yes. So resistivity is a characteristics property of any material, okay, which depends on nature of material, and second thing on temperature, okay, on temperature. So only two things it depends on. Generally it is a dimension free, students, means it does not depend on the length or area. When you talk about its SI unit, okay, so SI unit of resistivity is the ohm meter, okay. So here you can differentiate also between resistivity and resistance. So generally a resistance depends on the area and length of the conductor, whereas resistivity does not depend on the dimension, whereas the resistivity in this ohm meter and resistance unit is ohm. Generally metals or alloys have low resistivity, okay. Metals and alloys have low resistivity, that is in the range of 10 to the power minus 8 ohm meter to 10 to the power minus 6 ohm meter. But whereas for the insulators it is quite high. Insulators it is quite high in the range of 10 to the power 10 to 10 to the power 18 ohm meter. So this is the concept for today. Now we will try to see some numerical based on this. Yes, let us just try to solve. Okay, so here is the question I have written. Now let us try to solve. So the first question is that find the resistance of a nylon wire of length 1 meter and area of cross section 4 mm square. Yes, so very first thing what we do is, student, we write the data. Okay, it asking about what? Resistance. Yes, so what is the given? Given the length of the wire, length is what? 1 meter. Then the area of cross section, that is A is given 4 mm square, and the resistivity is given 100 into 10 to the power minus 6 ohm meter. Now we will see the physical quantities written. So these are its standard unit or not? Yes, so these are its standard unit. See, this is not. So we will convert it into the standard unit. So this will be become what? 4 into 10 to the power minus 6 meter square, because 1 mm is equal to what? 10 to the power minus 3 meter. So 4 mm square means 4 into 10 to the power minus 6 meter square. Now what do you know? What is the formula? R is equal to rho L by A. So substitute the value. For rho it is 100 into 10 to the power minus 6 into length is 1 meter, and by area of cross section is 4 into 10 to the power minus 6. So what we are observing that this will cancel out, so the answer will be 5 ohm. Yes, I hope so it is clear to you. Now students, we will see the another problem. What is given here? I will solve half for you and you will tell me what is the answer for it. Okay, See, very first, a copper wire has a diameter of 0.5 mm, resistivity 1.6 into 10 to the power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohm? How much does the resistance change if the diameter is doubled? So here the two parts of the question is, no? The first thing is asking about its length, and second thing is that if the wire diameter becomes double, then what is the resistance change? So very first we need to determine the length. So as we are having the formula here, now R is equal to rho L by A. So what we can write, L is equal to R times A by rho. So by that we can determine. So very first just try to write the data. Okay, I am erasing it. So very first write the data. Resistivity, diameter, no? So solution diameter is equal to 0.5 mm. Next, resistivity of the wire, that is rho, is equal to 1.6 into 10 to the power minus 8 ohm meter है, and length of the wire to make resistance. See, resistance is given, that is 10 ohm. Now, student, what we know? We know R is equal to rho L by A. So L is R times A by rho. Now you see, do we have the A here? No. So we need to find the area of cross section. Area of cross section का मतलब मैंने पहले बताया कि ये अगर एक वायर है ना, so this will be area of cross section. ये किस फॉर्म में होता है? इस सर्कल के फॉर्म में होता है. तो अगर हमारे पास में R है ना, अगर हमारे पास में R है, then you know area of cross section is what? Pi R square, है ना? तो but we have diameter, है ना? लेकिन एक चीज नोटिस करो, this is not in standard unit, so we need to convert in a standard unit. So this will be 0.5 into 10 to the power minus 3 meter. Now in standard unit अभी हम लोग फिर क्या निकाल सकते हैं? A, तो A is equal to क्या हो जाएगा? Pi R square, okay? That is pi R square. That is 3.14 into R की जगह में क्या? You know, diameter का radius क्या होता है? Half होता है ना? So what we can write? 0.5 into 10 to the power minus 3 divided by 2 square. ये हो गया radius और that is square. So now can we substitute the value over here? Yes. But I am implying length is equal to R की जगह पे हम लोग वैल्यू रखेंगे कितना? 10 ohm. ठीक है. एरिया क्रॉस सेक्शन हमारा क्या आएगा? 3.14. इसको you can cut it also. इसको हम लोग कैसे करते हैं? इसको 0.25 लिख लेते हैं. ठीक है. तो 0.25 का स्क्वायर minus 3 का स्क्वायर and divided by value of rho, that is 1.6 into, okay, sorry, I think it's not visible, no? Okay, let me erase it and write the top of the question. इसको हम लोग यहाँ ऊपर पे लिख लेते हैं ना, यहाँ पे. So L is equal to R का वैल्यू है 10 into A की जगह में हम लोग ये वैल्यू रख देंगे 3.14 into 0.25 into 10 to the power minus 3 to the whole square divided by, ठीक है, रो का वैल्यू कितना है? 1.6 into 10 to the power minus 8. So solve it and answer me what you are getting. Okay, just solve. You can pause the screen and try to solve and see whether the answer you are getting or not. solve students, you get almost 122.65. Very simple difference, no difficulty should be there. इसको आप सॉल्व करो तो you know 0.25 into 0.25 you can write 10 to the power minus 3 to the whole square मतलब 10 to the power क्या होगा 6. So you can cancel out, ये ऊपर चला जाएगा तो that can be easily cut. Now you will have the 0.0625 and can multiply with this one and then divide. So since I have already solved, so I am telling you 122.7. Now what is the second part of the question? It is asking how much does the resistance change? How much does the resistance change if the diameter is double? Means other things are kept constant, no? So for this, only what is made double? This diameter is made double, no? So what you can say, the new d dash will be the in times of d, yes, and then similar we can calculate it, students. You get the value 2 into 0.5 into 10 to the power minus 3. So from here you can have the r, yes, you can calculate that will be half of this. Now you have the length and you have the resistance. So can you calculate the R? Yes, rho L by A. Please substitute the value and see what value you are getting and write in the comment. Okay. So I hope that this session is beneficial for you. So bye for now. See you in the next class.